Right, okay. Limits of sequences. So I'm not giving you any notes in this because you've it all down already. I'm just going to remind you about it and explain how it applies to sequences. So you don't need to take down anything I write. Okay, you just need to listen. Okay, so imagine you have a sequence, right? Okay, let's just take an arithmetic sequence. So we go 2, 5, 8, 11 and so on, right? So we're adding 3 each time. Agreed? Right, okay. So what's the limit of that sequence? As in, what number will it finish up on? If it went on forever, where would it finish up? Tell me. If that went on forever, where would it finish up? What's the final number? There is no final number. It's infinity, isn't it? We keep going, get bigger and bigger. Agreed? Right, okay. If we had a sequence like 16, 8, 4, it's a geometric sequence, right? Okay, I'm multiplying by a half each time. Right, where will that end up? It will end up at, it's going to keep getting smaller and smaller, isn't it? So it'll never get to 0, but the limit is 0. It's heading for 0, isn't it? Right, remember limits? It'll never get there, but where is it heading for? Right, okay, so this one is getting smaller and smaller. It'll never get there, but it's getting nearer and nearer to 0. An 8th, a 16th, a 32, a 64th, right? It'll never get to 0, but it's heading for 0. So we say the limit of this one, the limit Tn, as n tends to infinity, so that means as n gets bigger and bigger, that sequence is going to get bigger and bigger. So the limit is infinity, as in it has no limit. It goes on, it keeps getting bigger and bigger. There is no such thing as infinity because, right, this one, we say the limit as n tends to infinity of Tn is, we say the limit is 0. Right, okay, as in it's getting smaller and smaller. It'll never get to 0, but it's heading for 0 all the time. Do you remember limits? Vaguely, please? Yes? Right, okay, right. So, just to remind you how to do limits, okay, so if we're getting the limit of, I'll do all the part ones over here, right, okay, the limit as, the limit of n plus 2 all over 3n plus, minus 4. Okay, I'll just do 2 things, right? Okay, if it's a limit as n tends to a number, as n tends to 1, right? All you do is fill in the number for n, okay? So if you fill in the number for n, you'll get 1 plus 2 all over 3 times 1 minus 4. So that would be 3 all over minus 1, which would be minus 3. Is that okay? So if you're getting the limit of a sequence, right, as n tends to number, fill in the number, right? Okay, is that okay? Right. If you end up with something like 3 over 0, if you're dividing by 0, the answer is infinity, right? And if you end up with 0 over 0, remember that's indefinite. Okay, so there has to be another way to find the limit. And in the other chapter, it was you factorize before you start, and then it'll work, right? So if you end up with 0 over 0, that's indefinite. You have to find another way to find the limit. Do you remember that? If you're finding the limit to a number, you stick in the number, right? If it ends up a number over 0, that's fine, that's infinity. Divided by 0 is infinity. 0 over 0 means you can't get the answer this way, you have to come up with something else, right? Okay, and the last thing I have to remind you of, if we're getting the limit as n tends to infinity, right? Which is what all these ones are, because these are Tn's and they want to know what happens as you move up the sequence, where does the sequence go? So n is always getting bigger and bigger. So all the ones in this chapter or in this section will be n tends to infinity, because that's how sequences work. N keeps getting bigger and bigger, right? Okay, Does anyone remember how do you get the limit of a sequence that tends to infinity? You can't fill in infinity for n because infinity doesn't exist, right? So what'll I do? Does anyone remember? Divide each term by the highest power of n. So you divide everything by the highest power of n. So you look at the formula, right? And what is the highest power of n there? 1, isn't it? So you divide everything by n to the power of 1. You divide everything by n. So it's the first term divided by n plus the second term divided by n all over this term, the bottom term, divided by n minus 4 divided by n. Okay? So n over n is 1. Right. 2 over n you can't simplify. Right? 3n over n is 3, and 4 over n you can't simplify. Is that okay? So the question is, where does that go as n gets bigger and bigger? Right? So 1 stays at 1. Right? 2 over n, as n gets bigger and bigger, where does that head for? 2 over n, as n gets bigger and bigger, where does that head for? Anyone? No. It's the number on the bottom is getting bigger and bigger. It's heading for 0. It's a fraction. So the bigger n gets, the smaller that fraction gets. Agreed? Like 2 over 10 and 2 over 100 and 2 over 1,000. 2 over 1,000 is really small, isn't it? So that's getting smaller and smaller. Would you agree? Right, underneath the line, 3 is heading for 3. 4 over n, where's 4 over n heading for? 0. So the overall limit of that is 1 over 3. So the limit as n gets bigger and bigger of that sequence there is 1/3. So it's getting nearer and nearer to 1/3. It'll never get to 1/3, but that's where it's heading. Okay, I'll do another one. Okay, so as n tends to infinity, yes, yeah, so as n tends to infinity, right, okay, the sequence is getting, where is the sequence heading is the question, okay, and if it's n tends to infinity, you divide above and below by the highest power of n, right, okay, so let's do this one, limit as n tends to infinity of n squared plus 2 all over n squared minus 4. Right, what'll I do? Divide everything by n squared. Divide everything by n squared. So it's the first term divided by n squared plus the second term divided by n squared all over the bottom term divided by n squared minus 4 all over n squared. Right, so that would be 1 plus 2 over n squared all over 1 minus 4 over n squared. With me? Now we're getting the limit of this as n tends to 0, or as n tends to infinity even. Right? Okay? So we've just simplified it, like we haven't changed it. Right? Okay? We've just made it easier to find the limit, because if we divided everything by the same number, we haven't changed it. So we haven't done anything to find the limit yet. All we've done is put it in a good form for us. Okay? So now, as n gets bigger and bigger, where does 1 go? As n gets bigger and bigger, where does number 1 go? There is no n, so it's going to stay there, isn't it? Where does 2 over n squared go? As that n gets bigger and bigger, where does that go? 0. It's heading for 0, isn't it? Right? Underneath, 1 heads for 1. 4 over n squared heads for 0, doesn't it? Okay, so the limit of that is 1 over 1. So 1 over 1 is just 1. So as n gets bigger and bigger, this function here heads for 1. Okay, is that right? Will it ever get to 1? No. Right? But as you kept going up the sequence, it's going to get nearer and nearer to 1. Okay? Are we good? Right, will you do this one for me? Done? So you've divided everything by what? N. So it's 5n over n minus 4 over n all over n minus 4 over n. So that would be 5 take away 4 over n all over 1 take away 4 over n, right, and that would be 5 heads for 5 because it's just a number 5, it's constant, it doesn't change as n gets bigger. 4 over n heads for 0, right, 1 stays at 1 and 4 over n heads for 0. So it's 5 minus 0 all over 1 minus 0, which is 5 over 1, which is just 5. Do we get it? Right, okay, one more before I move on to the next section, okay? So limit as n tends to infinity of n plus 3 all over n minus 1 all over n squared minus 9. Now, we have a choice here. You can multiply it out on top, or you can factorize on the bottom. Both work. So you can either multiply, you can't deal with, you can't divide by the highest power of n because these are multiplied. So you either have to multiply it out and have pluses and minuses between all the terms, right? Or you factorize, if you factorize below the line, something will cancel. Okay, are we good? So I'm going to factorize below the line. Right, okay, so below the line is the difference of two squares. So it's n squared minus 3 to be squared. So when you factorize, that's n plus 3 times n minus 3. They cancel, and you're actually getting the limit as n tends to infinity of n minus 1 times n minus 3. So you divide above and below by n, so it's n over n minus 1 over n all over n minus 3 over n. So that would be 1 minus 1 over n all over 1 minus 3 all over n, and then you get the limit. So the limit of 1 is 1. The limit of 1 over n is 0, limit of 1 is 1, and 3 over n is 0. So it's 1 over 1, which is just 1. Is that right? Okay. I'm going to give you a few of these to do now. It's too late to start the next section. Right, okay. So I'm just going to ask you to do let's do number 5. Right, okay, so I'd say you'll have it done, okay? So I don't need to put it up. That's me guessing. You'll have it done if you put your mind to it, as in you have 5 minutes, okay? It's not like it's going to take you 1 minute per question. So is it okay with you if I don't put it up? Just do it now. So number 5, can you see it? That could be why I need to put it up, is it? Will I put it up?
Excuse me, please. Would Rocio Revilio Pasquale call to the office at the bell, please? Thank you.
we all okay with doing these? So you divide above and below by the highest power of n. And if you end up with 0 divided by a number, 0 divided by a number is 0. Right, so your overall answer is 0. Okay, which is what will happen in part 1, I think.
Do we include the 3 when we're dividing over?
You'll end up with 0 over 3. Yeah? Do you end up with 0 over 3?
Yeah. No, I mean like we put the n squared.
No, you just divide by the n squared. You don't mind the number. Okay, girls. No homework.